Hello my dear students, in this video now we are going to learn about the hybridization and structure of the xenon fluorides. We know very well that xenon belongs to the noble gases and the general electronic configuration of the noble gases is Ns2Np6 and xenon belongs to the fifth period, and we know very well that each period starts with a new shell. So the electronic configuration of the xenon becomes as the 5s2 5p6 and it has empty 5d 5f and 5g orbitals. But in the formation of the xenon fluoride compounds, it utilizes the d orbitals. Now we go for the structure of the xenon difluoride. In the ground state, electronic configuration of the xenon is 5s2 5p6 and 5d 0. That means the d orbitals are empty. Now we know very well that in xenon difluoride two bonds are there because each fluorine atom forms one bond. So we have to take the xenon to the first excited state because when it undergoes excitation we get the unpaired electrons, and according to the valence bond theory, number of bonds is equal to the number of unpaired electrons. Here we require two bonds, so that's why we require two unpaired electrons. So that's why we require to take the xenon to the first excited state. So here first excited means breaking of the last electron pair. So in this first excited we are having the two lone electron pairs, and now the hybridization is, that means now the xenon undergoes the sp3d hybridization. And here in this hybridization each fluorine atom gives one electron and forms one bond with the xenon. So like that we get the xenon difluoride here. And in this one hybridization is sp3d and we are having three lone pairs. These are three lone pairs and two bond pairs. First bond pair and second bond pair. That means in xenon difluoride hybridization is sp3d and the number of lone pairs is 3 and the bond pairs is 2. If in this hybridization if it has no lone pairs, then it will get the trigonal bipyramidal shape. But as it is having three lone pairs, it is having linear shape. Xenon Tetra Fluoride, that means XeF4. The ground state electronic configuration of the xenon is 5s2 5p6 and 5d0. And in xenon Tetra Fluoride 4 bonds are there. So that's why we require 4 unpaired electrons. To get the 4 unpaired electrons, we have to take xenon into the second excited state. Second excited means dissociation of the last 2 electron pairs. By doing that, we are getting the 4 unpaired electrons. And here hybridization is the sp3d2. And in this excited state, each fluorine atom gives 1 electron to the xenon and forms 4 bonds. So look here. So in XeF4, the hybridization is sp3d2 and it is having 2 lone pairs and 4 bond pairs. And if the hybridization is sp3d2 and if it has no lone pairs, then it should get the octahedron. But as it is having 2 lone pairs, now the shape of the XeF4 is the square planar shape. We will discuss about the structure of the xenon hexafluoride, that means XeF6. The ground state electronic configuration of the xenon is 5s2, 5p6 and 5d0. And in XeF6, 6 bonds are there. So to get the 6 bonds, we have to get 6 unpaired electrons. To get the 6 unpaired electrons, we have to take the xenon to the third excited state. Third excited means dissociation of the last 3 electron pairs. So 1, 2, 3. So here, by doing that, we get the 6 unpaired electrons. And in this excited state, the hybridization is sp3d3. And in this hybridized state, each fluorine atom gives 1 electron and forms 1 bond. Like that, we get the 6 bonds. And here in XeF6, the hybridization is sp3d3. And it is having 1 lone pair and 6 bond pairs. If the hybridization is sp3d3 and if it has no lone pairs, it should get the pentagonal bipyramidal structure. But as it is having 1 lone pair, we get the distorted octahedron structure.